in this. You're going to hear a lot about AI. You probably have already, and both this morning in the keynote and many of the other sessions. And we're delighted to be able to offer our first ever AI training. Normally we deliver product training. We thought this time around, with the interest in AI and the focus on all of the various announcements that we're making this week, we've done a dedicated AI Masterclass as part of our new WebEx Academy training program. So my name is Damien McCoy, and together with Laura Hamill, and we're hosting the session. We're going to learn from experts in AI, and we'll introduce shortly. And they're hopefully going to tell you how you can both define and deliver an AI strategy for your business. What I would ask is if you can just get your phone out and grab the QR code from WebEx Space. We'll be sharing resources and information from the sessions in that space. We'd love you to also share your questions, your experiences with AI today, maybe some of the challenges and use cases that you're experiencing as we talk through them ourselves, and we make this as interactive as possible. So let me start with taking just a very few minutes to give a short perspective from what we are, just to set the scene. So AI presents a lot of opportunities. We're all seeing how it's transforming, it's enhancing, and probably more importantly, it's disrupting so many aspects of our lives, including how we work and how we get things done. And it's these possibilities and future opportunities that we'll explore this afternoon to see how you can design and implement an AI strategy for your business. So we'll explore new ways that you will work and how your business can compete with AI. Our aim this afternoon is to not just quickly to understand AI in your business, but to give you a guide on how you can best fit into it. If we look at how AI is impacting the enterprise, we can probably categorize it into three main areas. Firstly, it's enabling higher value tasks, allowing individuals to take on work that previously would have required superior skills, superior resources, or additional expertise. Secondly, it's providing us with super part problem solving ability, where we can now take on problems to scale or complexity, make them previously unsolvable, or certainly economically unsolvable. And finally, it's dramatically removing the complexity and associated costs of business processes, delivering efficiency gains which were previously out of reach, and we're taking on tasks such as reorganization, classification, and analysis of vast amounts of data in near real time. If we look at the numbers then, so you all know what a trillion is from the keynote this morning. Does anyone remember how many zeros? I certainly had to look it up when we put the slide together. Anyone on tip? Yes, so it's 12 zeros. 12 zeros is a trillion. So McKinsey considered over 60 use cases across 16 different job functions and estimated that the total productivity gains of AI were up to 4.4 trillion annually. These 60 plus business cases were where they determined a targeted application of AI for a specific business challenge created a tangible economic benefit with savings to the business. So 4.4 trillion is a big number. It's a little bit hard, certainly for me to get my head around. So let's maybe focus it in a little bit and talk some numbers that might be a little bit more easier to kind of get our head going. So if we look at individual verticals or industries, we can see that McKinsey has mapped that 4.4 trillion into different verticals. And we can see that the numbers are a little bit easier to understand. So in banking, they estimate that impact is 200 billion plus a year. And in retail or consumer goods, it's twice that. And probably in whatever industry you go in, the numbers very similar. And so it's clear that all industries and probably all roles or most roles are going to be changed by the opportunities of AI. And we're not taking these gains that others are going to take them in our markets. And so another interesting stat is when we assessed the last article with customers in a recent innovation study, we found that 84% of CIOs, IT decision makers, and developers are already using AI or ML to create better experiences for end users. We're not just getting productivity gains, not just realizing gains for business, but actually using it to serve your customers better as well. And you saw some of that this morning in our keynote too. So it's not just focused on productivity, it's also thinking about customer experience and also employee experience as well. This is greatly skewed towards enterprise. If you kind of go down out of enterprise and mid-size, down into small business, this drops to about 67% in the survey that we did. So again, it's an opportunity for AI to work for you, but potentially to guide your customers and the businesses that you might serve as a partner, for example, of how they can gain from AI as well. What McKinsey research heard from CIOs and CTOs is that they consider AI to be the technology shift of this generation. To take one discrete example for that, They illustrated by generative AI coding support has the potential to help software engineers perform code documentation 45 to 50% faster. So one small kind of discrete example, but you can imagine as you scale that up and apply it into your software development processes and your product development approach, you're going to have extremely large gains. And then another key aspect that Keith is going to particularly focus on, and Chris will speak to, is responsible AI. So as you'll hear from one of our speakers, it's a key part of any AI approach or any AI strategy. And so when IDC asked organizations like yours, when they relied or worked with an external service provider on responsible AI systems over the last 12 months, what was the top business objective of that exercise? Trust and privacy of data came out top by far. So trust, transparency, responsible use of data, and ethical application of AI must be central to any AI strategy. And you'll see that as we go through this afternoon. So just a quick show of hands, maybe to wrap up before I introduce our speakers and their content. Who considers maybe their organization is AI ready or maybe somewhat AI ready today? Okay. Everybody's hands going up. That's great. Good. Okay. How many would say they're not even kind of started think about it or just starting to scratch the surface on AI readiness and developing AI strategy? Okay, no, and then probably all the rest are somewhere in the middle. That's crazy. Okay, so hopefully we might have a slightly answer when we get to 5 p.m. this afternoon. Okay, so let me talk a little bit about our presenters. We've got a fantastic lineup here. And I'm just going to read out their full bios. I think it's important you kind of understand maybe who's going to come up here and speak to artificial intelligence and help us today. So first of all, we've got Michael Bernstein. He's an associate professor of computer science at Stanford University, where he's a vast university fellow and ST microelectronics faculty scholar. His research has won best paper awards at top conferences in human-computer interaction and has been reported in venues such as the New York Times, Science, Wired, and The Guardian. Michael's been recognized with an Alfred P. Sloan Fellowship, the UIST Lasting Impact Award, and Patrick J. McGovern Tech for Humanity Prize. He holds a bachelor's degree in symbolic systems from Stanford University, as well as a master's degree and a PhD in computer science from MIT. You're very welcome, Michael. Thank you for joining us. Chris Rowan is a Silicon Valley entrepreneur and technologist, now VP of AI here in Cisco's collaboration business. He served as CEO for 2 successful Silicon Valley startups, audio AI specialist Babel Labs, acquired by Cisco in 2017. And you saw a lot of Chris and team's work this morning in the keynote when the work on audio and video codecs was introduced. And he also was microprocessor designer, Telsilica CEO, which was acquired by Cadence in 2013. Chris was also a pioneer in developing risk architecture and helped found MIPS Computer Systems in 1984. He was named an IEEE Fellow in 2015 for his work in development of microprocessor technology. And finally, we've got Keith Griffin. Keith is one of our distinguished engineers here at Cisco Collaboration, who's focused on AI and machine learning in the office of our CTO. Keith has worked on features that include robotics assistant, noise removal, relationship intelligence, facial recognition, media transcription, and more, and has helped to form Cisco's responsible AI framework from NIPL machine learning data privacy through to today's responsible AI framework for generative AI and large language models. He's also led Cisco's collaboration IP patent and research strategy, and has been Cisco's top inventor for collaboration technology for over 10 years. He holds a PhD from the University of Limerick in Ireland related to the use of REST programmable interface design for real-time communication in web browsers. Great. So that's our speakers. You're going to hear a lot from them very shortly, and let's just jump to the agenda. So we're going to split this into 2 parts. We're going to run with Chris and Keith from now until 3 o'clock. We will take a break until 3:15. I'm looking to check whether that's right, is it? Yeah. We'll take a break for 15 minutes, give you all a breather. We'll come back at 3:15 for part 2. Please put that separately in your agenda if you haven't already. And then we'll hear from Michael in the second part, which will go to 5 o'clock. We'll have a quick Q&A and we'll wrap up. So without further ado, I will hand it over to Chris. You're very welcome. We get started. Thank you.
Thanks, Dave. So let me get hooked up here.
media AI is important, so need to have audio and video hookups along the way. So my task here today is to give you a sense about how we should think about building competitive advantage, building strategies to leverage AI in your organization, in your business. And along the way, of course, I'll use a few illustrations of how we've approached this AI strategy question within Cisco and WebEx. But it's not fundamentally about WebEx product. I think you've heard a lot about that in the keynote and in all the other side presentations. So this is really about how the fundamentals of what AI is and isn't that you can use to try and figure out what are the best ways to take the leverage of this technology with a great deal of latent power and actually make it useful and positive in the context of what your organization is trying to achieve. And so over the course of the next roughly an hour, I'll give you a little sense of what AI isn't and what it is. What are some of the things to worry about and not worry about with AI? And then spend really the bulk of the time talking about AI strategies, some of the key choices to make, and some of the key data issues. Because data is so central to the nature of AI. It is, at its fundamentals, a transformation in how we think about software. It's really a transformation from thinking about software coming from some recipe described in algorithmic steps to an algorithm which is really described by data and how that data is classified. And so understanding that life cycle of data, how you define the product, how you train the model, how you put that model to work inside of your system is really going to be a central recurring theme. So let's get some basics there. Fundamentally, AI is this much used, overused term. It's now, I think, the most widely used two-letter word in the English language. And it means a lot of things to a lot of different people. It's a term that's been around for 50 or 60 years, and it has continuously been redefined as the underlying technology has evolved. So once upon a time, it was really about expert systems. How could we, in a set of causal equations, capture the knowledge? You know, what did a doctor do when diagnosing, or something to do with theorem proving or representing knowledge? Increasingly, it has become centered on machine learning. This idea that we would create an algorithm by example, that we would learn from a mass of data what was or wasn't part of the answer. And within that, there has been evolution to ever more complex solutions. And in fact, over time, you can really think of that numerical modeling, which is at the heart of machine learning, as a layer after layer of equations. And when people use the term deep learning, they just mean that the number of layers in the layer cake is large. And the deep neural network probably means there are scores or even hundreds of layers of equations. And in fact, the number of parameters in those equations can be very large. And so that got called deep, which immediately meant that everything that came before it must be shallow. And there are a bunch of very powerful statistical techniques like doing regressions or decision trees or k-means clustering or support vector machines, lots of archaic and esoteric terminology about, you know, those prior methods that were the bright shiny thing that people in the machine learning area used. But really starting about 10 years ago, everything started to gravitate towards what we now call neural networks or deep neural networks, and with specific subcategories like convolutional neural networks and recurrent networks. And for the last few years, especially from large language models, transformer networks. And these are really details that you don't need to know about, but they all fit in this category of using data to configure and train an algorithm. And as the data became larger, we can contemplate deeper networks, bigger models, and bigger models then created an appetite for yet more data. And so the twin technological problems at the heart of doing neural networks is figuring out, well, what problem am I really solving? For example, is it a classification problem? That is a problem where I really want to say, well, what is it? You know, in the simplest case, is that a dog or a cat? Is that a car or a pedestrian or a bicycle? The question of prediction, given this history, what is most likely to come next? And in fact, generative AI is really an extension of that to say, well, let's predict the next word, and then the next word, and the next word, and the next word. In fact, let's string together whole sentences and paragraphs and essays and poems and computer programs. There's also anomaly detection, which is really asking the question, is this normal? What's different about this? Is this credit card fraud? Is this, you know, a car at the wrong place? Is the sound of that bearing on my factory floor off, such that I know that I should be doing preventative maintenance on that piece of equipment? Those are all anomaly detection problems. And of course, when you have these very large models, and once we met masses of data, you have both the challenge of where am I going to get all the data, and how am I going to train it in finite time. In fact, neural network training has become the supercomputing problem of the era. Supercomputers have been around for a long time. They've been used for weather prediction and weapons modeling and protein folding analysis and automotive crash analysis and many other highly compute intensive problems. But the grand challenge problem of today is, how do I train one of these trillion parameter models? And so the great consumer of advanced compute and the largest configurations are now used in AI machine learning training. And so there are a lot of shortcuts that we're looking for, ways of either making the training go faster or finding new ways to create data so that we can train these models. And we'll hear more later about things like reinforcement learning, which sort of turns the training process into a game. And Michael's going to talk some more about that. The idea of pre-training, that sometimes you don't need to take all those pictures of dogs and cats and label them explicitly. You can take data like pieces of English language text. And the mere fact that you know that somebody wrote that piece of text to make sense gives you an implicit idea about the grammatical structure of English. And today's large language models are 99% trained on just that raw data without any special data preparation, and allows it to know what is the structure of English just by the fact that essentially the models are trained on all the language, all the text that appears in the internet. There were methods like autoencoders that try to figure out what is the smallest, the way with the fewest bits that can allow you to compress and decompress the data. Data synthesis is really important. I'll come back around to that. And there's this really clever idea called generative adversarial networks. This is the idea that I'm going to create one network, which is attempting to create new things like, you know, new pictures of some kind, and an adversarial network that's trying to determine, is that a real picture or an artificially generated picture? And generative adversarial networks create kind of an arms race in which the generative network gets smarter and smarter as it gets feedback on which of its pictures were determined to be fake. And the adversarial network would get smarter and smarter about detecting the fraud, the fraudulent pictures versus real pictures. So all of these really clever ways of thinking about creating the broad diversity of data that you need to go on. So the technology has been maturing rapidly, and in particular, both new concepts and much bigger compute with much bigger data have powered it in an incredible way over the course of the last decade. So let's think a little bit about how to worry about AI. Now, some of this is a question that falls in the category of responsible AI and thinking about the ethics and utility of different kinds of solutions. And both Keith and Michael are going to spend time on different aspects of that. So I'm not going to talk about the worries of responsible AI here, but talk about a different category of worry. This is a worry at the organizational level. This is a worry about, am I moving too fast? Am I rushing into something? Well, it's still just, moving up the Gartner hype curve, or is this something big? Or am I moving too slow that all my competitors are getting way ahead and I'm not building up the fundamental know-how? And there are actually pitfalls on both sides. On one side, you could move too fast. That means you go into it unprepared. Your products are not high quality. It undermines your brand. Or you don't have sufficient controls about the IP, which are somehow absorbing into your models because you haven't been really very discerning about where that data came from. Or somehow your IP that you used to train is now creeping out into the marketplace so that other people can see your secrets just by using your model. Are you making a knee-jerk reaction to competitors' product announcements and therefore not really thinking through the differentiation of what you're doing? Are you, setting your whole product strategy by just reading the headlines of what other people are doing? Or are you moving too slow? Certainly there's been lots of angst in the industry, in all the industries, about moving too slow because the hype around ChatGPT and large language models in particular has been incredibly fierce since November 30th of 2022, when ChatGPT was announced or unleashed on the world. And I think there are some real worries there. That even if you take that whole hype with a grain of salt, there are real benefits in starting to move up the learning curve, of starting to figure out what it actually means for the future of your products and services. I think it's a question of making some of the deep sustainable investments, like attracting the talent and establishing some of the policies around data, about building some products, getting them out there and starting to figure out what customers really need and want. And all of this is really part of the cumulative effect of innovation. And so even if you have some uncertainty about what the long-term impact is going to be, there are real benefits of being out there and in the discussion with customers and attempting to build some products that use AI in some way. And I think over the course of the afternoon, you get a lot of ideas about how you might go about that, even if you're starting with very skinny resources and very skinny infrastructure. But let's think a little bit about building strategy. And I'm attempting here to get at some of the fundamental questions or trade-offs that you might face. And I'll throw in some bits about how we at Cisco have looked at some of those trade-offs. Now, of course, the uh, the business school model of product definition says, well, you always start with a customer and you figure out what the customer wants. And then you define a product that meets those customer needs. And then you go to engineering and you ask them to build that thing that the customer wants. And that's an excellent model, at least some of the time. But sometimes there are such discontinuities in the technology that lots of things are becoming realizable even faster than customers have internalized what it is that they need next. And so you get to a little bit of a chicken and egg problem, that there are now lots of products that we could build, and sometimes relatively few or relatively unimaginative things that customers are actually asking for. And we could say, well, customers didn't ask for it, so why should I provide it? Well, I mean, to some extent, your job is to solve what the problem of the customer, what the customer needs, even ahead of when they have recognized that they want it. And so part of our job in doing fundamental technology is to anticipate, to figure out where the puck is going, to figure out where is the combination of as yet unmet needs and technology opportunities, technology possibilities, and start crafting those new experiences or finding ways to achieve operational efficiencies that just were not conceived of prior. And so it's always this mix of figuring out what customers are asking for, better yet, what they should be asking for, if they really understood, if they really could step back completely from their current solutions, and figuring out what is becoming possible. And I think that AI, just as any other kind of inflection point architecture, tends to open up a period in which there's lots of room to push some technology upwards in anticipation, not just in response to the customer needs pushing down on the product organization. I think that one of the good examples of that is the AI audio that G2 talked about this morning's keynote. This is something where the media AI team recognized, based on a long history of experience in building better audio noise removal, bandwidth extension, speaker selection, speech recognition, that in fact we have entered a period in which we could fundamentally recast the problem of speech encoding. And instead of thinking about, oh, that's a problem that needs tens of kilobits per second to accurately represent speech, we can do it in an order of magnitude fewer bits. So that became a technology opportunity. And then we got to take that raw potential and think about it through the lens of customer problems. And the customer problem was not generally, oh, audio uses too much bandwidth. The more pervasive problem is that audio doesn't get through on the network all the time. That lots of bad things happen to audio packets as they go around the world, and they get delayed, they get dropped. Things happen to them such that if you're on the receiving end of in a low latency audio communication system, you sometimes will get very nice clean audio, and sometimes you get because those packets did not arrive when they were needed. So they did not arrive at all. And so we were in a position to say, okay, this new encoding gives us lower bit rate, which means we could go with less traffic, but it also means we could have much higher redundancy in what we do send over the network. And that can give us much higher network resilience so that we would no longer care so much what subset of the packets got through, which could give us super robust audio. So we turned a technology opportunity into solving what was clearly a need. We did not have customers saying to us, we need a more redundant codec system so that audio can be more robust. In fact, this idea of the packet loss interrupting the audio has been around so long that lots of customers are like, it's just a fact of life. Then stuff happens. But by going back to the fundamental technology, we could in fact solve a problem that customers had long ago given up on trying to solve. And so we created this new codec, which here with more of the gory details of what G2 showed before. This is the Opus codec. These are other modern research codecs, which have successfully been pushing down on this curve of how many bits does it take to encode a speech stream. And on the vertical axis is speech quality. Xcodec is the internal name or what we call the AI codec. And what you can see is that it's got a very flat curve that goes all the way down to 1 kilobit per second. So 16x fewer bits for the same quality of speech as you get today in the industry standard Opus codec. That's the great enabler. And it allows us to build that improvement. And what does that mean? Well, it means that you can take audio, which started out feeling pretty good, something like this.
Today, we are introducing a path-breaking innovation, a novel neural network-based speech codec designed to address the challenges of low bit rate audio.
Loss of packets, either intermittently or continuously. We'll take a fairly extreme case here. 75% of the packets didn't get through. And if you don't do anything about it, you get this. You get a little bit coming through. This is not what you want to listen to for an hour at a time in the meeting. But when you turn on the resilience features, when you recover what is latent from the replicated packets and for the healing process of interpolating between lost packets, get this.
Today, we are introducing a path-breaking innovation, a novel neural network.
Basically, you get everything back. So that's really kind of transformative. There's a lot of emerging detail in terms of how that codec is built and how it's trained and how the packets and the replication are wrapped around it. But that's the kind of thing that you can do with AI technology. It's the kind of thing that you can do when you're thinking simultaneously about customer needs down and technology opportunity up. Another one of the classic problems in forming an AI strategy is figuring out what do I build for myself and what do I buy in terms of AI components in the open market. And depending on your technical capabilities, depending on what data you have available, depending on what time frame you're looking at, depending on your demands for differentiation in the marketplace, each of them plays a meaningful role. Clearly, when you build your own AI, especially if you do it well, you can solve unique problems. You can solve the problems that your customers have rather than some other generic problem that might have been in the minds of the creator of some building block outside. You can leverage your specific access to data, your specific domain expertise. You're essentially encapsulating both your domain knowledge and your AI know-how. And it gives you an opportunity to control costs, to control latency, to control privacy, and to maximize the differentiation. And in an area like audio and video, which is an area of deep expertise for Cisco WebEx, we build all our own models in audio and video. In other areas, many companies, including Cisco, use a mix of building and buying AI building blocks. Why do you buy? Well, it often gives you faster time to market because you didn't have that whole training process. You took something that's kind of off the shelf and then you build the system level solution around that. You're often therefore able to leverage industry know-how. And you can put your focus on what's the system solution. What is the specific problem that the customer has that you're trying to solve? And in that sense, you're reserving your AI capacity for some other kinds of problems. It should reduce your development costs and it maximizes the compatibility. It's in some ways easier to explain to the customer what it does if you can point to external sources and say, oh, we're built on standards. So in areas like language modeling components, we use a combination. In many areas, we leverage pretty deep expertise in natural language understanding. A lot of that for us came in through our acquisition of MindMap, which has been a long time leader in natural language understanding, modeling, and bonds. But we also leverage third-party and open source large language models, like the ones you hear about. And in fact, as we talked about, there has been an explosion of those models and different levels of size and sophistication and quality of results. And depending on which problem we're solving, we use one from a spectrum of different large language models to solve those problems. In fact, I think that idea of make versus buy and integrating other people's technologies into our own proprietary solution versus building top to bottom proprietary technology shows up in the architecture of the AI assistant. So this is the platform which we built to really systematically handle this wide range of advanced language features across WebEx Suite and devices, WebEx Connect, and the contact center. And so the way to think about this is a unified user interface, a vocabulary, a style, a template, and how commands and queries and notifications are designed and presented to users. And under that is a series of services, a query service, a summary service, a control hub service, an agent service, a composer service, which do those specific tasks on behalf of those users. But those are built on top of a platform of internal services. Think of it as the backplane in which there are unified ways to access large language models. It's kind of this unified orchestration layer that YouTube talked about, which we call internally the LLM proxy, which allows us to unify the methods for access to both proprietary third-party LLM services and open source large language models. It also is a way for us to have a unified and automated way to plug into third-party APIs and third-party databases and other customer-specific plugins and common database. There's a corresponding transformation in the nature of data representation in databases that comes from the explosion of use of these large language models. Now, in the past, you thought about a database in which you made queries that might be by field or value. But now we have the opportunity with semantic embeddings and these meaning-based representations of text, just sort of query by idea. You don't need an exact text match. You just need to have a phrase which you can map into a meaning, which can match against the meanings of prior conversations or emails or documents. And this idea of search by meaning is an incredibly powerful way of unifying the access to information across your organization, because it's much less dependent on exactly what format it was. It can be independent of what language, what source, what words used. It really gets at the essence of purpose. And so this combination of plugins, LLMs, and semantic database creates a structure in which each of these services becomes significantly easier to develop, has significantly higher transparency of access to the necessary information, and more extensibility and scalability into the specific context. What tools do you use? Do you use Salesforce? Do you use ServiceNow? Do you use, an airline reservation system? Whatever is appropriate to your environment can be built into this fundamental structure. Here's a third idea that I think is kind of valuable in wrestling with the strategy question. If you think about all the different tasks that take place in your organization, there's a big range of time scale and detail that you deal with. Some things are happening in your organization second by second. If you're running a factory, there's some flow of material down the production line or through some continuous chemical engineering process. Or there is the progress of your vehicles in the world, or there is the moment by moment conversations that are taking place between people. The personal, that often happening out there in the field. The endpoints, the sensors, the phones, the laptops are centrally important to where that data is captured, where that data wants to live. And you really often want to keep that data out there because you neither can afford the cost of transporting it or storing it, nor want the exposure of bringing all that sensitive data into the cloud. But as you move up this conceptual hierarchy, you think about, well, what's happening over the course of a session? Maybe it's, the processing of one, product down the assembly line, or it's the conversations within one site over the course of one meeting. And then you get to the level of what happened across my workday, what happened in my region. And ultimately, you reach this point of aggregation, where you're really thinking about, well, what happened across my local organization over the course of a quarter? And so as you move up this hierarchy, you get to subtle questions, more complex questions about how do I interpret, how do I distill what is reality? How do I see the forest for the trees? But down at the bottom, the trees are really important because that's where data originally comes from. That's where a lot of the fundamental new insights about what's going on can be captured in the first place. And so you really have this spectrum between very massive data with very tight timelines on these real-time streams. I want to actually do as much computation as possible there because it's actually easier to do the compute where the data originally originated. And I ultimately want to get the deepest insights at the top of the pyramid. And so thinking about the design of a product or a strategy, which can balance these and put this pyramid into the context of your organization. What happens in the field? What happens in headquarters? What happens second by second? What happens month by month? Is pretty important. One interpretation of that in the context of the WebEx product is thinking about scope across our different kinds of AI assistant architectures. So sometimes we're thinking about, well, how did I remove that lost packet, that 20 milliseconds of audio that I lost because some packet got stuck in a router queue someplace. Sometimes the scope is a single conversation. What happened over the course of that 30 or 60-minute meeting? And in fact, a lot of the things that we're announcing today and shipping now or in the very short term fill in that first column of what happens in a single conversation. What's happening in a message space? What was a summary of what happened in the 10 minutes I missed? What was the summary at the end of a customer contact center conversation? But what you see already starting to happen in the product, and which will accelerate over time, is that we move from a single conversation to what's happening across multiple conversations. What happened in all the meetings I missed during that week of vacation I just took. I need to aggregate more. I need to abstract it. I can't look at the details because I'd be overwhelmed. I'm not going to even look at every summary of every meeting that took place because I don't even have enough time for that. I want to get the gestalt, the overview of those things. I want to move from the treetop level view to a 10,000-foot view. And then ultimately, I want to look at not just the conversations, but now I want to plug in documents and email. I want to look at databases. I want to look at a whole picture. And I still wanted to have that leverage of large language model summarization and composition and queries. And ultimately, I want to make it personalized. I don't just want a generic perspective of the things that happened during the week I was gone. I don't want the same summary as the other guy who took vacation the same week. I want to know about what I care about. So we're also figuring out how do I build a profile from my past history of everything I care about and craft that summary or that query response or that recomposition around my style, my responsibilities, my hot buttons. And so you see that in things like the personalized space summary you see. And so we're gradually moving the whole thing up that pyramid in order to give a better and better, more personalized, more complete, and appropriately abstracted view of all of these things that we're doing. And so that over time, we will fill in more and more of these boxes. That's sort of the what's behind the curtain part of this picture. Now, as I think you come to understand, data really is the lifeblood of these machine learning applications. This is where this very fundamental shift in perspective from algorithm description to database description comes from. And I think there are a couple of really interesting elaborations of that it's useful to share. Clearly, everyone at this point, knows at least the words. Data is really important for training AI. And that really is the big consumer of the masses of data. And when we train our audio codec or our noise removal, we're talking about millions of hours of noisy audio. In fact, noisy, clean audio pairs used to train those models. And for the training of the large language models, they're so large, they need trillions of words of information in order to form that complete picture, to get that deep structural understanding of what is a sentence, a paragraph, a story, a character development, a poem, a program. But that's just one piece of it. In fact, one of the techniques that we found very useful is thinking about even the original specification of the function being described largely by data, not by somebody writing in English some algorithm or describing some sequence of things that this new function will do. So in addition to describing, well, what is this through the eyes of the customer, we also build a whole suite of examples of what it is that we expect as the input and the output of these functions. And it's often very clarifying, both to the data team, which is now going to need to go create a diversity of data to go solve this problem, to scale that up from a handful of examples, potentially to millions of examples needed to train. But also to get people to think about what is the measure of success? What is the quantitative metrics that we're going to need to apply to that function to actually know that we got it right? So the data is used in specification, the data in massive scale is used in training. We also need to reserve some of that data, not used in training, explicitly not used in training, to test whether the function really did what we asked it to do. And in fact, it needs to be very diverse, at least as diverse as the conditions, the users of that function ultimately. So we know whether we've got it to an adequate level of accuracy and that it works across all the different classes of users. I think we're going to hear a lot more about responsible AI, and data diversity is one of the fundamental considerations in knowing that you're actually representing and supporting our users appropriately. And then ultimately, you take that model as characterized and tested and proven, and you put it into production. And then the live data starts happening. And you need to continue to monitor that data to see if the way it's being used in practice is really what you expected. And there are simple things. I mean, suppose you're training some sensing seeing system that is used in, running your aircraft operations or your chemical factory or your bank. And people or chemicals or airplanes behave differently in winter versus summer. If you collected all your data in summer, and now suddenly you've got winter data coming through your system, you need to detect that and say, oh, I screwed up. I forgot that was a variable that I need to cover. And so I now need to expand the data that I'm using to go think about that. There's also some interesting paradoxes. Clearly, the most realistic data may be the data that came directly from your customers. You take that live operational data. But that's also the most sensitive data. And so you need to think about, do I have rights to that data? If I include that data in some way, is there any chance that that's going to be exposed? And at Cisco, we are very careful about this question. We understand that customers are obsessed about the privacy and security of that data. So we have to apply enormous scrutiny to protect our customers' data rights, to make sure that that data is not being used inappropriately. That data is not have any chance of being leaked, and this is not creating any benefit to anybody else but that customer themselves. And that's a really interesting, hard technical problem itself. So know your data, figure out what's required for both fairness and robustness, and figure out how to keep an eye on that data so that you know what's happening. In the case of WebOS, we do a number of kind of interesting things along the way. Data synthesis is one of those things, and it may seem counterintuitive that we're actually using algorithms to create the data that is then used to train the neural network system, which isn't based on algorithms. So we're just substituting an algorithm for the network. And the answer is not really, at least not if done right. But let's take a question like, well, how do you train an audio codec or a noise filter to separate speech from noise? There are a lot of variables in the world. There are lots of different speakers speaking a lot of different languages, with a lot of different accents, in a lot of different acoustic environments, how much reverberation, a lot of different noise environments, how many breeds of dog, how many types of airplanes, how many leaf blowers Could there be? There's even the effect of upstream codecs. What happened to that voice signal in terms of how it was compressed and decompressed and compressed and decompressed before we got a chance to fix it? A lot of those things actually can be physically modeled. We can model the rooms, the microphones, and therefore we can take independently created clean speech, microphones and noises and rooms, and create essentially perfect mixes of speech and noise. So we can take clean speech and make it noisy. And that means we can take noisy speech and make clean. So we are using physics of the rooms and the microphones, for example, to allow us to have this enormous diversity, which allows us to have very sophisticated models that can then unscramble the egg and essentially get the yolk back out. That is the clean speech. In something like conference room video, there's analogous kinds of problems. And it turns out in conference rooms that it's a very noisy visual environment. There are patterns on the walls, there are pictures, there's party balloons, not just faces. And one of the key things we want to do, of course, at a conference is to be able to track and model and understand those faces, because that's really the core thing that we want to communicate. And so one of the techniques we developed is diversifying the video by creating 3D models of thousands of different scenes. And then we make very noisy backgrounds, very diverse people in gender expression and age and skin tone and hairstyle and clothing and everything else. We even add in party balloons and soccer balls, because soccer balls and party balloons tend to get misrecognized as faces in a lot of cases. And so we dramatically increase the diversity of what we train our visual models on using these 3D modeling techniques. We even build avatars that is creating an enormous range of diversity of individual people with different hair and skin tone and glasses and headwear, so that we can have a really big range of condition. Once upon a time, we sort of captured, well, okay, let's go into a conference room and record ourselves. And you got a lot of pictures of middle-aged nerds as the training set. Well, of course, the middle-aged nerds are not what the world looks like. At least not completely yet. And so we really have worked to apply some of these other techniques. In some cases, we want real data. We don't want to use custom data, but Cisco happily runs very large internal IT support for Cisco employees. And so we get those Cisco internal IT calls as one of the sources of data as templates, examples, test data, training data for our customer support environment. We also develop new large language model generators for conversations. We augment that with open source data, like, NPR Car Talk, Click and Clack, Tom and Ray, great source of a pseudo customer support. And we reinterpret this. We have a significant team of in-house linguists and labelers and language experts that create that. Now, for your problem, these three particular kinds of data manipulation may not be at all appropriate, but within your own organization, there is some latent sources of data or modeling opportunities that will help create more data. So while you are building a strategy, the world continues to evolve. And here I want to talk about some of the fundamental technology shifts that are really the plate tectonics or the climate change that's taking place independent of what you're doing on a day-to-day basis. Because some of these are things that may be really valuable to anticipate, to figure out which things are going to get easier because the technology is favoring it, or which things may get harder because it represents increasing headwinds in the creation of your AI strategy. And this is just 3 of those to think about. I think if you keep thinking about it, there are lots of shifts, particularly changes in society that I haven't attempted to capture here. But these are technology shifts that are taking place. One, we are seeing larger and larger models and more diverse models. So, here is a little bit of an evolutionary tree just of large language models and just representing the last 5 years. And so what you see is there were a few models that were created, sort of down here. The BERT model in about 2019 was one of the models that really got the large language model thing started. We now look at the size of BERT as a large language model and chuckle because it's such a small large language model. It is a couple of orders of magnitude smaller than what we see happening out here, maybe 3 orders of magnitude, maybe more. But it created the first sense that there was a really different behavior that was becoming possible with these large language models. And it spurred a whole lot of investment across many companies. Google poured it on, and OpenAI poured it on, and Anthropic, and many others, both in industry and in academia, to come up with variants, often larger models, often models with novel training methods or novel interfaces. And it created this world in which every week there's a new large language model to consider. And it's very hopeful for those of us who are building these applications, because the choices are getting richer and richer, and implicitly the costs are going down and down, being able to put these to work. Now, we're going to hear more about some of the challenges later, the IP issues, the hallucination issues, the bias issues. But at the same time that there are plenty of things to work about, there's also new techniques to overcome those problems. And in particular, for a lot of the organization and business and industry applications, one of the recurring challenges is, how do I take a foundational model, which was really built on the idea, well, let's scrape the internet every year or so and use that large body of knowledge to go train a model. Well, that model is only going to know as much as was publicly available on that particular date when you scraped the world. And so it's largely ignorant of anything that happened since that date, and it's essentially ignorant of everything that happened inside your organization, because presumably that's not public on the internet. And so how do you ground it? How do you take a model which knows everything about that was on Wikipedia circa 2021 and every other public website, and make it something that knows what conversation you had with your boss this morning, and make it know what your internal policies are, and make it know what your proprietary code looks like. So that's the process of grounding. And how you adapt is now typically a combination of several different techniques that you can use in some things. You can say, well, I'm just going to pick up that data and make it part of the question. And Michael will talk some more about how you take, the context of the question and the question itself, and answer questions using these foundational models. Essentially, it's saying it's all part of the question. But these models have a finite input size, and in fact, the cost of processing it is proportional to the amount of context that you give it. So, if you had 1 million bytes of context instead of a kilobyte of context, that would cost 1,000 times as much to compute. not something that scales very nicely from a feasibility, economic, environmental impact standpoint. Another technique is fine tuning. You say, well, I got this model that's generic, but now I'm going to do a little extra training of it. I'm going to train it with my specific knowledge. I'm going to teach it the sensitive information, the recent information, so that really becomes part of the model itself. You can also use adjacent techniques like retrieval. So instead of saying, well, I'm going to make every conversation that happened last week part of the input, which could be very expensive, I'm going to say, I'm actually going to search to find all the relevant stuff. I'm going to find that small subset of all of last week's conversations that relate to the exact question I have. And so I filter and gather the relevant information from databases, from conversations, from documents, and I supply just those. So I get that thorough grounding without the explosion of context that would come from saying, well, let's just feed the whole damn history of the world into my model. And these are some of the techniques that you use to exploit the capabilities, but also the limitations of the evolving large language models. The second thing, which has been a real enabler so far, and which we expect to continue to be a tailwind, is accelerating compute capacity. In fact, if you look over the history of the compute requirements, this is a log scale. So each step is an order of magnitude. Actually, no, this chart, each step is 2 orders of magnitude in compute requirements. Over time, we've seen this steady increase, which for decades really followed Moore's law. The semiconductor technology got denser and more capable. But really, at a certain inflection point, a decade ago, neural network training, AI training became important enough that people really started optimizing the computers to be good at it. And so you had not just Moore's law, but a lot of specialized architecture, often in the style of GPUs that came into work, and the pace of improvement became much steeper. And in fact, we took another step upwards in terms of compute capacity as the large language model era came into work. So we've seen these methods that really come from thinking of it not just as a, oh, chips need to go faster problem, but chips need to be much, much better at the particular combination of multiplies and adds that make up the heart of the AI training and AI implementation. And so measured in compute performance, the fastest machines on the planet, the most efficient computers on the planet, are the ones that are dedicated to doing these machine learning tasks. That plays out as well in what's happening, not just in the big training servers with thousands of high-end NVIDIA GPUs, but what's happening in your phone, in your laptop. And in fact, what's inside that CPU chip is going through a fundamental change right now. It still will have that CPU, that Intel ARM CPU that does the general purpose software. But because of the nature of AI compute, we can leverage architectures which do a lot better at those multiply adds, and they've shed their capabilities for lots of other capabilities. And the first round of that is in GPUs. There's a lot of similarity between what you need to do for 3D graphics and what you need to do for machine learning. And so the GPUs have been enlisted to do a lot of this. But you can do even better. That there's a new category of computation called neural processing units or neural engines, which are even lower power consumption per operation, even lower cost per operation, and which allow you to push the compute capacity per chip much higher. And so these AI workloads, especially the implementation of the architectures that you find at the edge, where a great deal of that audio processing, that AI codec, that super resolution are really being implemented now on those GPUs, and especially now migrating to the new neural processing units, because they're so much more efficient. It almost is free compute. And so the cost of implementing AI from a computing standpoint is going down and down and down. And that's something which is another big tailwind for the proliferation of AI. It also has the curious side benefit that if you can compute locally, you do all this analysis and you tear apart, the audio and the video to get just the thing you meant, find just the gesture or just the face or just the speech you cared about. You can improve the privacy stature for the whole system, because you now only have to communicate upwards to the rest of the system, to the cloud, only those distinct aspects of the trees, so that you can get an overall view of the forest without revealing the bark of any tree. And we see an expanding set of things which will now fit. So in the past, it's been speech enhancement and video operations, but we will see speech to text and text to speech, and maybe even modest sized large language models migrating down to the edge to have this privacy preserving, energy efficiency, cost efficiency becoming much more available for these tasks. So let me finish on this kind of philosophical note that when we think about what we're doing, this is not fundamentally in the context of Cisco, in the context of the conversation business that WebEx is in, about figuring out how to replace people with machines. This is about augmenting those conversations. Michael will talk about this contrast of artificial intelligence and intelligence augmentation. And what we're doing is very much in sync with that idea. In fact, you can kind of look at the brain and our neurological understanding of different regions of the brain and what kind of processing takes place in which clusters of neurons, and say, okay, this kind of AI tool happens to be a boost, a supporting service for that part of the brain. So in fact, there's the auditory cortex in which the brain captures speech and works out the basic sounds. The speech production area called Broca's region. That's really where noise removal and the AI audio codec come into play. You have the visual cortex back here, where we take those vague shapes, captured by the retina, and turn it into object identification and mapping and attention. When we move up from speech to language, we're really invoking areas like something called Wernicke's region, which is where key parts of language understanding takes place. And ultimately, the prefrontal cortex, where, of course, awareness and reasoning and comprehension and creativity appear to be centered. And that's really the analog or the target, if you will, for getting from word sequences to understanding and concepts and decision making. And so, in a sense, we are figuring out how we create these external aids to different parts of the human perception and cognitive process, supporting creativity, supporting the communication, supporting that magical process of how individuals think and how organizations work. So thank you very much. And I hope that we'll be able to take a bunch of questions at the end without can. And so with that, I'm going to turn it over to Keith Griffin, who's going to start digging into some of the key questions of responsible AI.
Thanks, Chris.
Have fun.
Give me a second here. Just it. So good. And the task of following that fantastic presentation. And I'm going to cover here our view on responsible AI or generative AI. So what I'm going to do is share our journey in responsible AI, including some of these new challenges associated with generative AI. Chris highlighted some of those, but we'll go a little more about in some of those areas. First of all, what I want to do is look at your relationship with AI and also to share our responsible AI framework. This is something I think that will be hopefully useful to you as you set out that AI journey and how you implement a view of responsible AI in your organization. Sorry, on the agenda, what we'll do after that is look at generative AI relative to responsible AI, the care about areas. So what are the key areas of generative AI that present risk that we need to focus on in terms of responsible AI? And then also building on what Chris talked about in terms of some of the architecture and design principles that we put in place about how we implemented generative AI. We're still in the midst of building that, so I'll share what we have so far. I wanted to start with a message from our CEO as he talks about AI. What Chuck has said is the acceleration of AI will fundamentally change our world. Cisco is committed to being a trusted partner to customers and to helping them navigate this transition in a responsible way to deliver on the promise of this technology. The two key words for me in this are trusted and responsible. It's such such an amazing set of technologies. But we're all here because we're somehow in enterprise environments, or maybe corporate environments, or small business, whatever it might be. That view on a degree of trust and responsible application of AI is absolutely critical. So this is just an excerpt from Cisco's privacy benchmark infographic, and I put a link on the slide to this. I encourage you to go look at the entire piece. At some point, there's a lot of really useful information in there. Picking out a couple of the key data points, 92% of respondents felt they need to do more to reassure customers about data. That's a lot. That's like everybody, and it's good. It's good that people feel that they would need to do more and want to do more about data privacy. It's also interesting to pick up on topics like AI ethics being reported, which is really the core of responsible AI. I also find it interesting that it's quite low on giving customers the opportunity to opt out of AI use. That's something we spend a lot of time actually designing into our controls, the ability to opt out at an individual level or at an organizational level during the configuration of any of the features. I think it's really important that we have that to offer that type of choice. So I was really happy at the beginning of the session when Damien asked the question if you felt your organization was AI ready. You didn't put your hands up, because if you had, I wouldn't have much to talk to you about because you'd already be there. And there wouldn't be much to learn. So I have a few questions that I wanted to ask as well by show of hands, if that's okay. How many of you use an AI feature or AI at all in your organization right now? If you do, okay. And then within that set, how many of you use generative AI, like say ChatGPT or a generative AI service in some way? Okay, then let's know. And then the last question is in terms of say level of technical depth. How many of you actually develop AI solutions, like hands-on development around AI? Okay, very good. That's great. That's loosely what I have for here, so I won't have to adjust too much, but I wanted to make sure to check with you first before doing that. So I want to take a look at how you may interact with generative AI. I found this framework from McKinsey, which I really like because I have a much more comprehensive way to describe this, but some people thought about a much more clear framework. And they define your interaction with generative AI as being either a taker, a shaper, or a maker. So a taker is somebody that consumes a generative AI service. maybe just connect to ChatGPT and, do some function with that. Then you're a taker. It sounds bad, but it's not bad. It's just consuming service. So it's a good thing. A shaper is somebody that uses techniques like maybe fine tuning on a foundation model or some form of customization to achieve an outcome that defines shaper. And a maker, so somebody that's actually investing in creating your own type of generative AI service or model. So I think the question to ask yourselves is like, what are you in that? You may be more than one. At Cisco, we're all of those. And in collaboration at Cisco, we're all of those. You saw on the keynote this morning some of the new types of models we're making, some of the work that Chris's team is doing in terms of real-time media models. We also customize and tune, as Chris just mentioned, we consume services to deliver the right type of feature functionality that we need. Now, the interesting piece also is the underlying bar here that your posture for responsive AI may vary across one of these. Clearly, if you're a maker and you're building, you need to have much better investment in your responsible AI posture. That's not to say that it shouldn't be right for being a consumer of this. There's still a lot involved. I need to look into a lot of those areas. So let's take a look at generative AI relative to responsible AI. And there's a case for why generative AI. We heard a lot of that from Chris, and we're going to see anything more broad and really interesting from Michael later. But some of the benefits of generative AI are the ability to accelerate automation. Also, very specifically in creativity and productivity for individuals and for teams. There's a lot of opportunity there in areas where you might create. So a simple example might be, I recognize that people here from our partner community. Let's say you're a Cisco partner and you want to do something like create an AI strategy for your organization. You could ask a generative AI service to define that relative to Cisco and relative to your business. It won't create it for you, but it might get you 40 to 60% of the way there as a starting point. Then you can adjust and add to that. But ask yourself the question, how long would it have taken you to write half of the document in the first place? You get it in seconds. It would have taken, an elapsed time of maybe a few days to get to that, between writer's block and everything else, right? And we just will take that amount of time to get it done. And the same goes for areas like code generation, bug fix, and there's a lot of potential productivity gains. And what we're seeing, the reason for it is that really generative AI has crossed the threshold of technological and economic viability. Although, these are the large models, as Chris mentioned, and they are expensive to run and to consume, but still they provide that benefit. And another one just taken from the list here is the democratization of access to the technology. You no longer need to be a data scientist to be able to actually achieve these types of results. And you will see this from Michael's session later with some really interesting exercises that we'll all do about just how easy it is to get started. And it's largely a case of getting started. After that, you're maybe bound by your imagination. So there's a new barrier, a lower barrier to entry from that perspective. So let's ask yourself the question, well, what could possibly go wrong? So I'm looking at this through three different lenses. The first is the business risks. I'll just pick some of these. There's a lot of very well documented risks out there, and I would certainly advise to go and search some of those out and familiarize yourselves with them. So things like IP infringement. You ask a question, you get an answer, you use that answer. But what if the answer is not yours to use? What if you ask them about a particular type of coding problem, you provide them with some code, that code that you're providing was actually sent in by somebody else, belonging to someone else with a different question. I think the line that the LLM made me do it probably won't stand up in court, right? So you need to think carefully about the output that you use and where that came from. And I would say that many of the large language model and generative AI vendors have very rapidly improved the terms and identification and so on around how that output could be used. But you really have to pay attention to that. The same with things like copyright infringement. Say you generate a new logo, but where did that come from? If I ask you, for example, a model like DALL-E to generate the Cisco logo in a style of Picasso, that's great, but there's maybe a Picasso Foundation that might have something to say about that. And you have to look at you have to look at the sort of position on how you use that particular element, what the risk is to your business. And yeah, there's a whole bunch of others. That's all I wanted to just leave here as reference. And then if we move next to the user risks or the risks for the user, there's potential for violation of privacy laws, disclosing private information that you maybe don't intend to happen. There's a lot of unintended consequences in general as a theme here. There's new security vulnerabilities with things like prompt injection attacks. We'll talk a little more about prompting soon. There's also accountability for output and accuracy and trust in output. If I'm a user of a system and I get an answer and then I use that answer in some way, but I fully trust it, yet I maybe got it wrong. You have to question at all times the answers and the outputs that we're getting. So there's a lot of risk to the user. And I know I'm probably making this sound it's like terrifying, but they're just you need to be aware of the risks and then find mitigations and find ways to address them. And then finally, on the model and the training data. So if you're a maker, certainly you're maybe modifying or creating your own model. There's a lot of interesting technical items to pay attention to. There's the ever-present risk of bias. There's new concepts associated with large language models like concept drift, which is the statistical properties of predicted output change over time. There's when it comes to bias, Chris touched on this briefly earlier, but you have to consider what both your algorithmic and data bias that you might introduce in the system and what the outputs might look like as a result. One of the areas we applied this was in the area of virtual background replacement. So, I was asked the question before, well, does it represent the opportunity for gender bias? It really shouldn't. Nothing really ever should. Well, the caveats in an area like background replacement are the edges. So the difficult things to do when you're applying a virtual background, like my hand gaps in here to paint those foreground versus background or hairstyles is huge. So actually, you might choose to intentionally have a biased data set with more female than male data there because there's a great variety of hairstyles. And as a result, you have an unbiased result in the output. So it's actually more about hairstyles than gender, probably as that's maybe where you're tracking there. So to make decisions like that, to maybe intentionally bias your data in order to get to de-bias the results. It's a very, very fascinating area to work on. It's also fascinating to watch practitioners and data scientists apply as much art as science to getting that right. And then about how do we manage this risk, right? So like I mentioned, it sounds terrifying. If you look at anything on that chart, you probably never get started. But the key thing is really to manage the risk, understand it and manage it and identify what we do about it. And you see this evolutionary tree already, but I use this first to work with our legal team and our procurement teams to talk about how we might get a process in place to allow ourselves to work in this area. And I thought it was a really fascinating way to show it because really the approach that we landed on, what we want is maximizing guidelines and guardrails and minimizing approvals. I would say we made mistakes on that. We tried, we tried to take an approval first type of scenario where, okay, you want to use let's pick one on the chart here. You want to use the VAR model. Let's go through like a large approval process for that. And then 5 minutes later, somebody wants to use ChatGPT or PAM to. It's the same thing all over again. You just can't scale to be able to approve all of those. But what you can do is put a set of guidelines in place in your organizations that say, here are the things we care about most in order to create those guardrails. We come back to those care abouts in a few minutes. But these best practices and guardrails have served as well to enable teams to go develop in these areas. What I want to do next is look at some of the important concepts around interacting with a large language model. And to look at that through the lens of responsible AI, not just the development of this. I'm sure you have an interesting demo of this. First one is the concept of prompt engineering. And Chris mentioned it earlier. And I want to take a look here at like, why would you prompt? And why am I considering that important from a responsible AI perspective? So you prompt because large language models are sensitive to input. And it can help to reduce ambiguity in the output, which makes the output safer. And it can also enhance performance. And what is a prompt? Prompt is the input that you make to the large language model. So let's say I have a set of messages in WebEx, and I want to summarize them. The prompt will be the instruction to summarize them and how I want that done. And the body of text of the messages. That's the prompt. Very commonly used term, large language models. But the instruction is critically important. The output I would get if I said, summarize these messages professionally versus summarize these messages in style of rapid will yield a very different result. Right, and we'll see. I'll show you some of that in just a moment. But I want to use this example that I found on Medium blog, which I really caught my attention because it really illustrates the dangers and the safety net that prompts can provide. So on the left side was a prompt that says, I saw a woman and her husband in the parking spot trying to change the tires. Who was less efficient changing the tires? A, the woman, B, the husband, or C, no answer. And the answer the large language model presented was a woman. Now, it has no information to give that answer other than the fact that it's biased in its training. It's trained on the world, and unfortunately, the world has stereotypes and bias, and that's what it came back with. It's wrong. So if you're an organization providing this type of output, you're creating exposure and risk. That's not the type of answer that we want. If you look on the right-hand side, prompt is updated with the additional instruction, ensuring that your answer is unbiased and does not rely on stereotypes. Now it gets the correct answer, which is C. There's no way to answer the question. There's not enough information to know who's less efficient. But it's a great example of how just tuning on that prompt and creating the right type of prompt will give you a safer and more accurate answer. And I put the link here to the blog. There's a lot more really interesting information around prompt engineering. It's one area that I encourage you to focus on a lot if you are starting to do more development in generative AI and large language models. Invest in understanding prompts and how it's going to make a difference. And I'll show you an example of that in just a moment. The other technique that I want to expand a little bit on was fine tuning. Sorry, I should have mentioned also on here, as Chris mentioned earlier, RAG, retrieval augmentation generation. So that uses an external data store during the inference step to build richer prompts. So you can kind of automate prompts that bridge what the large language model knows and your own knowledge base, which is very useful again in enterprise environments. So that's a technique we're looking at to help increase the richness of prompts. Moving away from prompts and towards a more hands-on machine learning type approach is fine tuning. We'll talk about this as well later and talk about some of these, some of the techniques that I have on the next slide associated with it. But fine tuning is now applying your own tuning on top of the foundation model if it supports that. Not all of them do. And that's good for domain-specific tasks, data privacy, compliance, user experience. And in general, customization and personalization. And there's a lot of different techniques that were actually machine learning techniques in their own right before this advent of generative AI and large language models, like reinforcement learning and reinforcement learning with human feedback, transfer learning and adaptive learning. These are techniques we've used for years in our conversation of AI and technology as standalone techniques. They're now very useful in this fine-tuning area. So what I'm going to do at this point is just pause on the content here and switch out to the demo to show you prompts in action and the difference that it can make. So let me just end this and go here to, this is Slido, our audience engagement tool. And this is a question answer on an all hands type of meeting, right? So here I have a question that's come in, which is Cisco's a leader in collaboration with awesome AI can we win? So I could ask it to improve the wording. I could shorten it. I could ask for a more professional tone or a casual tone, although I suspect that it's written casually enough as it is. I can use some fun things like ask it to speak like Yoda. And here we get like a Yoda style answer back with the sufficient backwards speaking. I can't say that. I can ask it to make it rhyme. Let's see where it comes up with. In the realm of collaboration, Cisco leads with might. With awesome AI, they aim to shine also bright. But amidst their grandeur, a question does arise: can Cisco emerge victorious in this enterprise? I wouldn't have come up with that. I don't know if that comes up with that. I think it's great. But what's the difference? The difference simply is the prompt. Like the question remained the same all the way through, but the prompt instruction asking it to return something or change the style is what generated a different type of output. So that illustrates just the power of prompting and what the difference it can make. This is in a positive way, an intentional way. But think about it as that safety net. Like a simple prompt to add is only answer if you're 100% certain. That's a good prompt. It can make the outputs kind of a bit more basic, but you're going to catch accuracy issues because it's a good big stop. Unstop them and or reduce the risk of hallucinations. Where if it doesn't know the answer, it will make one up and just keep going and like the politician. That's something that is common in large language models, right? It's hallucinations. So let me switch also to a demo using my actual WebEx app. So it's always risky. Let me what's going on here? Yeah. I have no idea what's going on with the UI with something to the yes. Let me just launch WebEx again. Yep. No, just does not want to fit on that page. I'm just going to bring this out here. This is my actual app. What I'm going to do is go to a conversation. I'll pick one here. This automated testing might be a good way to, or a safe way, I should say, to download. But let's pick a conversation that I have with one of our patent attorneys on a patent filing for something that was in the keynote. So we needed to get something in pretty quickly. And I can go over here. This is what you saw in the keynote this morning. This is a developer version of the app, so you wouldn't see this in your own WebEx app. But I can click on the assistant and I can ask it to summarize my unread messages here. And it's going to summarize what Andy has sent to me. Right. So it's getting it right. I can see that as it's reading, right? So now what I want to show you, the reason I wanted to do that was to show you a developer feature. Again, this is not something that will ever show up in the app you've ever seen. That's what we're using internally to develop and manage the development of this. It's our AI prompt studio. So it's on my other screen. I'll bring this up. Put this over here. And this is the prompt studio. It's showing the actual prompt that is used. So what it was asked to do here was professionally summarize the conversation below in a single paragraph, making reference to the person who said each thing. That's what we landed on as a prompt. We also have a bunch of parameters here that the temperature is set to the default of 1, but if I modify that, that will change the creativity of the response. I could look at the parameters further down, like the frequency penalty or presence penalty. The same words were repeated a lot. I can adjust that so I can adjusting the response I get back. These are kind of like nerd prompts that we get to dial to get a safer answer when it comes to response to AI. But let me just show you just how simply changing a prompt could change the output. So instead of asking for summary in a single paragraph, if I ask for bullet points and then generate again, it will know what to do. I'll just get the prompt will now change the output to be bullet point based. And again, that's just showing you a functional type of output. But the reality here is that you can really use these to make a safer type of output, by putting the right guardrails around that. So let me go back here. We start this. But I thought it's useful to show that. I know it's very much like under the hood. That's an internal tooling that we're kind of like local audience here, and increasingly, keeping that as an internal tool. But you will develop these types of things in your organization. You will need to figure out, well, as you interact with a large language model of some sort, what sort of tool you want to put around it. You may develop it yourself. You may use some off-the-shelf types of tools, but it's important to do this as opposed to just send some input to a large language model and get some output. It's a great leader I worked for before, constantly reminded me hope is not a strategy. So hoping it will return the right answer or what you intend is will generally be okay. But if you can put those guardrails around it and maybe focus on things like prompt engineering, you're going to be in much better shape. So I mentioned we come back to the generative AI thereabouts. So when we started out in this area, we were, we acquired MindNow in 2017, which was a language model-based data science workbench for conversational AI. And in 2018, that's when really a lot of the large language models like BERT and various others started in their development. And we've been focusing on this area since then. But when it came to giving ourselves permission from a responsible AI perspective to build features and externalize some of this, we started focusing on and asking ourselves what really matters to us and what do we need to do to work across Cisco to be able to make it okay for us to use this type of technology, given that we have so much customer data that passes through, and we, would not risk that. The first thing that I would recommend for all of you is to create a place to go play. You need a sandbox, whether even if you're not developing, even that tool like this show that we developed internally, just being the flexibility to throw some text in and see what the result is in a safe kind of way. So we wanted to have a developer sandbox, and we did that with non-confidential data. So we would just use synthetic data or test data to figure out what those outputs might look like. Not a lot of development required. You're going to get a great exercise later in the second session to actually try this type of stuff out. The next thing we looked at were some of those technical care about items like accuracy, trust in output. So if you send an input, is that what you expected to get back? Like the wine example was probably beyond my expectation. I mean, pleasantly surprised with that as a response. But is it what we expect? And also, is it consistent? And if I use multiple large language models, do I get the same or some approximation across all of those? Because you probably want to do those types of evaluations. What's the right generative AI service for you? It also gave us a chance to look at costs. So these are expensive to run, and as Chris mentioned, it's the costs are dropping. At the same time, if you do something at scale, it's going to cost. So understanding what that cost model would look like. On the functional side, it gave us an opportunity to look at things like prompt engineering that we just looked at, and fine tuning, and the security, and what sort of controls that we need to put in place, like opt-outs and various other controls. So these were really important items. And what we did with that is we used that then to work with our legal procurement teams to say, these are the things we care about most. So if we're going to use a service or an open source model or train something ourselves, we want to be tested on all of these items. So if somebody says, like a third party organization says, you can have sandbox and, it's a really great deal on economics, but when we take all the data and train on it forever, that's just not going to pass for us. And these are the types of things that I encourage you to think about. And I'd encourage you also strongly to create those partnership groups in your organization with procurement, with legal, with great people team. That's very, very, very much takes to be able to enable them. How can we enable engineering to do something? It's a great posture, I think, that they've got. We have this real spirit of getting it done. The easy thing to do is say no, right? But we have this great spirit of getting it done. How we all partner together in order to be able to create and release generative AI services. So the next area, this is probably like a core takeaway that I want you to have from today's session, which is the responsible AI framework that we've been putting together. We've been working on this for years at this point, well before generative AI, but we've adjusted it for the new challenges that I mentioned that generative AI presents. The framework is two parts, yielding one result. The two parts are a set of 6 principles and then a framework, and that yields the result of responsible AI by design, which is what we take from a sort of a DNA type perspective. So we question really at every decision point what those will be. And by the way, these are published on cisco.com. So we'll be able to find these, and I've got some references in here as well. So I really want you to take this part away, and we have all of this published on cisco.com and on Trustable, where you'll be able to find this. The framework, like I said, is put together 7 years ago when we were doing more supervised machine learning techniques like noise removal, face rec, WebEx assistant. But we felt we needed this. We started out looking at it from a data privacy perspective and then expanded it from there. So we have 6 principles, which are reliability, security, privacy, fairness, transparency, and accountability. And I'll just very briefly cover each one of those. From a reliability perspective, it's on us and maybe on your organizations to look at creating robust models if you're developing them, if you're using them to ensure that they are robust, because by testing around them, Chris mentioned earlier the separation of training and test data. What are you testing? What is it consistent? And are can you be confident in your results? Next is security. So considering threat modeling and data protection, amongst other factors in the design. Can the model be compromised? Can it be made to do something other than it's intended for? That unintended use, not intended output. So making sure that that's a core part of our development cycle. We already have a secure development cycle. We added AI machine learning considerations to that. The third one is privacy, which is where it all started for us when we started looking at machine learning data. So looking at data privacy in the training data and prompts by design. I'm going to give an example, a practical example of how we did that for noisy removal shortly. And then next is fairness. The key word here really is bias. And looking at avoiding algorithmic data bias, like the example I gave from virtual backgrounds earlier. Next is transparency. So this is about sharing sometimes our core designs. So face recognition is a good example of that. I share the entire design of how we do that because we have an enterprise data privacy centric model and we use that like a consumer centric model for face recognition. And I felt it's important to do that, even though it discloses to our competition how we go and implement this feature. It's important to give comfort to customers to show that this is used for things like name labeling, that it's designed out of the system to be able to get used for other purposes like surveillance. It just can't do that. And that's always the scary piece that's associated with face recognition. So sharing the core design shows a level of transparency and then builds comfort to the customer and user that this is all it's able to do, and here's the compelling use case and benefit of the design. And then finally, accountability. So being able to stand behind your models or service that you're providing to your users and your customers by conducting assessments, responsible AI assessments, and testing that they behave as intended, as well as that they cannot be used in an unintended way. Then, in addition to the principles, we have a responsible AI framework that consists of governance, incident management, external engagement, controls, and industry leadership, and generally staying on top of this. The one I would pick out here from this list is incident management. So we've created an AI machine learning incident response team. I'm on along with some other colleagues. So if you find a bug or an unusual behavior that you think might be related to AI or machine learning, you can raise that against Cisco. You'll come to us with triaging to see could it be related to data or algorithm or something related to machine learning? And I'm not aware of, too many others in the industry that would have that type of response, incident type of response to management in their process. And then next is the responsible AI assessments and the high level development process around that. We have a responsible AI assessment process that focus just on, as we're releasing a machine learning feature, have we cared about fairness and all of the principles. But what we did was expanded that for generative AI to do things like upfront vendor or third-party assessment, if those are being used. If not, then we apply it to ourselves for in-house or open source models. During the development cycle, we apply responsible AI framework to things like data classification and privacy. And then post-development, or while we're in customer trials, we look at things like the development process adherence, continuous improvement, monitoring, and then that incident management framework that I mentioned. This is maybe an interesting one for you as well, which is looking at the selection and procurement. I mentioned the need to work closely with your procurement teams and your legal teams. We created 3 personas around this. One is that I just want to play around with generative AI tools and learn it. We made that really easy for people. But they can't present confidential data. You can use test data or publicly available data and nothing confidential. But no barriers to entry, really easy to get started. The next is I want to use an improved generative AI tool or service. So we've now already improved this, and you just have to go through some response